Well, we'll let other people fill in, but I think it's safe to maybe start. I'll start off with just saying welcome, everyone. Seriously, we really appreciate you guys joining. The topic of today is just going to be self-hosting Semantic Scholar data, specifically through that Datasets endpoint. And so we'll be going over all the tips and tricks and kind of a step-by-step guide, specifically using AWS infrastructure, and I'll go into that more in a second. But for those of you who don't know me, my name is Seth Watson. I'm one of the co-founders of Mora.io. We are an AI research platform focused on literature reviews. And so a part of our journey of building Mora has been working closely with the Semantic Scholar team and deciding to self-host. And so for the past 8 months or so, I've had a lot of fun working with this data and kind of bringing data management in-house for us. And so I've consolidated all of my knowledge and packed it into kind of an introduction to you guys. And so these are all the things that I wish I would have had when I started. And so I hope that you guys make great use out of it. And without further ado, I think we can kick in. There is some housekeeping that I want to go over really quickly. I want to bring your attention to the right-hand side of the screen and just put a face to both Chris and Ashley, who are awesome resources to you. If you're not already, if you haven't already introduced yourself to them, I'd highly recommend it. And they have been absolutely critical for us and just helping any questions, concerns, or updates about the Semantic Scholar API and broadly just about the community. So a couple of notes: the webinar is being recorded, as Chris mentioned. The recording itself and the deck will be shared with you guys after. And then you can ask questions anytime in the chat. I think we'll be monitoring it. And if we have time at the end, we're going to do a Q&A session. And so we'll try our best to answer all your questions there. If we don't get around to your question, we'll reply via email or on Slack. And lastly, I just want to do a quick call to action. If you're not already in the Slack community, please join. I'm sure most of you are, but it's a really awesome space. Everyone there is super nice and helpful, and we're all working together kind of. And so I love that. And Ashley, I don't know if you want to post that Slack link in there in the chat for anyone who's not already joined. So with that said, welcome, guys. Like I kind of hinted at earlier, this is a culmination of kind of everything I wish I would have had when I started. And so we're going to walk through pretty much the key steps into self-hosting the academic data, like I mentioned. We're going to do it all through the AWS free tier, and I'll go into that in a moment of why I chose that. But with that said, hopefully by the end of today, you're going to leave knowing exactly how to leverage AWS to store the pre-signed URLs that are coming from the Datasets endpoint into S3 buckets. You're going to query across them using AWS Athena, and we'll talk about practical applications. So all in all, we're going to do an introduction, benefits of self-hosting. We'll do an overview of the datasets themselves. We'll walk through that step-by-step guide for you to essentially for free self-host initially. And then we'll talk through some practical examples, some more advanced options, and then we'll wrap everything up with Q&A and some suggested next steps. So let's hop into it. I think the first question that we should answer is, why should anyone self-host? And so as I go through and talk about this, I'll also share the reason why we at Mora decided to start self-hosting. So ultimately, self-hosting just offers you a lot more flexibility than if you were to just use the Academic Graph API. And I remember it was maybe about 7 or 8 months ago, and we were writing out our user stories and kind of ideating on the features that we wanted to build for Mora. And it was really clear as we started to build out our technical requirements, we needed to self-host. We couldn't just rely solely on that Academic Graph API. And so we were reaching into data quite frequently. I was running into that 429 error quite frequently. And so that was like the first note. Secondly, we were trying to join data and really ultimately what Mora is like a custom data analysis pipeline, if you will. And so all of that pointed me in the direction that, okay, self-hosting was the right decision for us. With that said, there's definitely instances, excuse me, where self-hosting might not be relevant for you. And those would probably be like the first example I think of is if you're a student writing your dissertation and you have a really hyper-focused subset of papers that you want to work with. It doesn't make sense for you to go off and download millions and millions of papers to get those. And so I'd like to maybe call that out. Also, if you're wanting, I have a second bullet point there over real-time data retrieval. The way that I view this is essentially by self-hosting, you have the responsibility to stay up to date with something called incremental diffs. So these are weekly releases by the Semantic Scholar team that shows the papers that they've either removed or added to their corpus. And so if a part of your use case is you need the most up-to-date released papers and you don't want to create a pipeline to update your current corpus, then you might want to rely on that academic graph API. But all in all, self-hosting for me, what it represents for me is just it really has unlocked a lot of the dream features that we wanted to build at Mora because it gave us the ability to kind of bring data management in-house, create really custom bespoke pipelines, and unlock like some super powerful features. So with that said, we'll kick over to the next slide and talk about prerequisites. Now, before I do that, I do want to point everyone's attention, and actually, if you want to share the GitHub repo URL in the chat. So for those of you who don't know, there's a completely free open source repo that I created for you guys. And this houses, essentially there's two really important files and a really important README with extremely detailed steps. So I spared no details going through kind of the exact steps that you need to get up and running with a simple and free infrastructure to self-host. So I'd highly recommend all of you to open up that URL. You can favorite the repo, so you can star it, or you can bookmark it yourself. But this is an extremely helpful resource that will just get you guys going from 0 to 1. And then, of course, I really thought about making it extremely scalable. And so I recommend everyone to rip this apart and make it your own. And so I want to draw everyone's attention there before moving forward. So with that said, let's talk about some prerequisites. I think the top one that you see there, the use case, it's definitely not like a technical prerequisite, but I view it as an extremely important one. And so having a use case and this area will really decide a lot of your data needs. So we'll talk about the exact differences between the data sets in a moment, but without having a defined use case, if you just go off and download all 10 data sets for the 200 plus million papers that are out there, that you might not actually need that. And so I would suggest all of you guys to think about what are you trying to accomplish. If you can, box that into a user story and then create some technical requirements saying, okay, with this user story, I only might need the papers and abstracts data set. Or maybe I want to get full text, so I'm going to lean on that S2RC data set. But the point is, I would suggest a prerequisite to before moving forward is develop a use case about what you're trying to accomplish, as this will really allow you to put your blinders on and focus on what matters most to you. Secondly, you'll need Python 3.8 or above. You will need an API key. And so if you don't have one already, you can request one from the Semantic Scholar team. Turnaround times vary. And so I would just be patient with them. There's a lot of people who request API keys. Feel free, if you haven't received one in like a week, send Chris or Ashley a quick ping on the Slack channel. But I would ask that you be patient with them as they get a lot of traffic into that API and request. Fourthly, you will need an AWS account to follow along with the GitHub. Am I sharing the actual slide? I don't think I am.
Oh, we're looking at the self-hosting GitHub repo right now.
I'm so sorry, guys. Forgive me. Okay, so backtracking, I was supposed to be sharing this slide. My apologies. So we talked about a use case and what the use case means. Moving on, you'll need Python 3.8 as I mentioned. We talked about the API key. You can request it directly from the team. Fourthly, you will need an AWS account to follow along with what we created in GitHub. It's completely free to make that account, and you can follow the link inside of the README to go create that account and follow those instructions. Fifth, you will need basic knowledge of Python and SQL. If you don't, just get resourceful, like lean on chat, lean on Claude, or whatever LLM provider you want, and get really resourceful about describing what you are trying to accomplish. And it's really great at writing SQL queries. It's really great at correcting code. It's really great at implementing error handling, and we're going to talk about that later on. So just get resourceful there if you don't have the knowledge. Also, feel free to ping me. I'm happy to help you guys as much as I can. Lastly, an optional tool I put is Postman. And so it's a really great tool for you to test API calls before actually implementing them in quote unquote production. So I'd recommend you guys test your API calls. I want to draw your attention to the right-hand side of the screen, and I just shared a sample toolkit of what I use. And so I use Semantic Scholar to get that API key, right, and get access to those pre-signed URLs. I use AWS to store data. I use GitHub, or in this case, we're using GitHub to clone and use version control. I use VS Code for my editor, and then Python and SQL as well. So let's hop into it. Now, next we're going to talk about the overview of the data sets themselves. And I'll try to be as basic as possible and then kind of work my way up. So the data sets are essentially just data sets of academic data, and they're partitioned out into 10 data sets in total. Once again, not all data sets would be relevant for your use case, so I really recommend that you think about your use case and then think about what are your data needs with that use case, and therefore decide what data sets you want to download. Another call out is that the data sets can be either streamed or downloaded. Right now, the repo is set up to stream data from those pre-signed URLs into an S3 bucket that you configure. But if you wanted to, for example, download onto your local, you can definitely do that as well. That's an option. Lastly, on that bullet point, the data sets can be filtered on retrieval. There's a fantastic example on, I think, the AI2 GitHub, where I think it's called streaming and filtering .py or something along those lines. And that's a great example showing that you can actually filter that data before you start downloading if you don't want to just take it out of the box. Lastly, on here, I'll just note that the data sets themselves, there's 10, as I mentioned. They can be joined by 3 different primary keys depending on what data sets you're trying to join. The main primary key is the corpus ID. And so let me see if I can zoom in here. And you'll notice across the data sets, you'll see corpus ID. And so that's the main identifier without a doubt. However, I want to draw your attention that if you wanted to join, for example, the author's data set to the paper's data set, you need to use that author ID, as corpus ID is not present in the author's data set. And lastly, if you're wanting to join the publication venues data set to the paper's data set, you'll use this ID field as your primary key to join that data over. But before moving on, I want to call out inside of the repo itself, and I'll kick back over to the repo really quick. I have a file here called samplelines.json. And so it includes all sample lines from every data set that's available to us. And it's really helpful when you're thinking about your use case and what your data needs are. Go look through that sample lines, look at the exact data that you're getting, look at the fields that they are. Are they arrays? Are they structs? Are they booleans? Are they integers? And you can get a lot of that information there. Really helpful later on if you're writing queries, SQL queries, to reference back to that sample lines to kind of guide you into saying and defining like your tables, right? You're defining what fields you want. So highly recommend everyone references that samplelines.json. Ticking back over, I'm going to go to the next slide. And so here's where we hop into that step-by-step guide. So there's 4 steps that we'll be doing. We're going to clone that GitHub repo. We'll set up AWS. We'll download the data or stream the data. We use those interchangeably. And then we'll query that data. And so I want to pause here and talk about why I chose AWS to share with you guys. The main reason is AWS offers a very generous free tier for the 2 services that we'll be using, which is AWS S3, and that's where we're going to store those pre-signed URLs in the JSON files. And then also AWS Athena, which we'll use to query through that data. And so I want to just call out another really great benefit is with Athena, we can query through compressed files, so zipped up files, which is what they are. And so just once again, getting you to the point where you can get your hands dirty, look through files, and work with data, I just felt like S3 and Athena were a really great option for you guys. However, depending on your use case, Athena might not be the best option for you. But without a doubt, that download data sets will help you and get up and running and actually having that data on your side. Let me see if I missed anything else here. I don't think so. I'll just draw everyone's attention back to that GitHub repo. We'll share these slides with you, but this is hyperlinked to the repo itself. And so once again, if you haven't already, go favorite that repo, bookmark it, whatever you want to do. But there's a lot of helpful information and files there. So let's move on to kind of the first step here, which is we'll clone the GitHub repo. Pretty simple. We're just going to do git clone in the URL, and then we'll navigate to the project folder. Secondly, just adhering to kind of software development best practices, we're going to set up a virtual environment. And so depending on whether you have a Mac or Windows, you can run those 2 commands. Thirdly, we will install the requirements that are listed inside of the repo. And then lastly, for this, we're going to copy. I made an M-file template. And so you're just going to copy that template. And so what I'm saying here is copy it and name it .env. Moving on, we'll turn our attention to setting up AWS and our M file. So once you've created your free AWS account, you'll want to navigate to where you can set up an IAM user. And so we'll create a new user and we'll add 2 policy permissions. We're going to add Amazon S3 full access and Amazon Athena full access. This will allow us to programmatically have those resources on our side. So really important that you set that up. And once again, in the repo, there's very defined step-by-step guide into how you will accomplish this. So I urge you to reference that. Once we create that user, we're going to create an access key to add programmatic access on our end. And so you'll get the option to either save those keys or you'll get the option to download a .csv file with those keys. I'd recommend that you download it and save them somewhere. Who knows, you might need those access keys later. You can always delete access keys and then regenerate them, but I would just recommend you save those keys, especially for the next step, which will update our .m file to add the credentials and variables. And so I'll zoom in here really quickly on what we're going to be adding. And so we'll add our AWS region to our .m file, the access key and the secret access key that we just created in the previous step. For the S3 bucket name, this can be named anything that you want. Granted, if you created an S3 bucket on the S3 UI, so within the AWS site, you'll just need to make sure that that name reflects inside of your M file. Secondly, or on the point of customization here, and the Athena output bucket, I have it just set right here to whatever I name my bucket name, and then I'm just doing /query-results/. And so essentially what I'm doing is I'm storing my query results with inside of the bucket that I'm storing the data sets in, just for the sake of consolidation. But if you wanted, I know many people who prefer to have their query results separated in another bucket. You just need to make sure that that URL reflects here. And lastly, the last thing we'll add is our API key. Once again, if you don't already have an API key, you can request one from the Semantic Scholar team. And now we get into the fun stuff. So I want to introduce you guys to this file, which is called download_datasets.py. And this script completely simplifies streaming that data or downloading that data from those pre-signed URLs on the datasets endpoint over to an S3 bucket that you define. And so before running the script, we need to make sure that we configure it. And so the first thing that we'll do, I think it's around like line 54 or 58 inside of the file, you're going to add these dataset URLs. And so what these are, I'm going to zoom in really quickly. These are the URLs that house the files, those pre-signed URL files of each dataset. And so what I'm doing is I'm defining the dataset_URLs, and then I'm adding a prefix, and this is what our object folder in S3 will be named. So it'll be named papers, and then all of the pre-signed URLs that are inside of this URL, it's going to store those in the object folder of our S3 bucket. And so here I'm just saying get the papers dataset. Depending on your data needs, you can add other URLs here. You just need to make sure you separate them by a comma and add a prefix. So for example, if we had a data need that we needed both papers and abstracts, all we need to do is add the papers URL, and I'm saying just get the latest. You can get other releases as well. I'm going to separate it by a comma, and then I'm just going to add this up to the top. So I hope that makes sense. Feel free to ask any questions about that. And I'm happy to provide clarifying answers there. But once we have our datasets added, we're going to just run the file. And so a couple things to note. Before running, let's just make sure that our M file is correctly configured with those credentials, our S3 bucket name, and our API key. Secondly, the script will automatically create an S3 bucket for whatever your S3, what is it called? Bear with me. Your S3 bucket name variable there. So it's going to check if it exists. If it doesn't, it'll create it. And so this is, once again, if you're manually creating your S3 bucket on the S3 UI, you just want to make sure that name reflects back inside of your M file. Lastly, the process itself takes quite a bit of time just out of the box. However, we'll talk about in a couple slides how you can optimize this and how I optimize personally. But there is a progress bar there for your own tracking. And so you can see exactly how much longer it has to go, how many more files it has to go, and you can see that progress bar. So we'll move on to the last little step here, and I want to introduce everyone to the query_datasets.py file. And so this file simplifies essentially taking those compressed JSON files that we're storing inside of our S3 bucket. It simplifies querying them, and we're going to query them using SQL. And so before running the script, there's a couple things that we want to configure, and that is particularly since we're using Amazon Athena, we need to create a database and a table. And so I'll draw everyone's attention to this top side of the screen. And you'll notice what I'm doing here is I'm saying create a database, and I'm going to name it webinar. This is just like an example I threw together. And then within that database webinar, I'm creating a table called papers. And I'm grabbing these fields inside of the papers data set, and then I'm taking from the particular location that it's being stored in. So that's all that is. Now, once we create our database and table, we're going to need to add whatever we named it inside of the actual file itself. So you'll find these statements that you'll need to put. So just place the name there, and you can run the file itself. Once you run this file, it's kind of like a little bit of an out-of-the-box search app, if you will. Really rudimentary, really basic, but I wanted to provide just a little something to you. But it does a lot of things in terms of scalability. So you'll run this file and you'll get these options inside of your terminal, which is choose a query to run, and you can either find papers by journal, author, or field of study. And then lastly, you can also run a very custom query. So whatever you want, you can write. Before moving on, a couple things to note about this file. You want to make sure that that M file is correctly configured with your Athena output location. And then secondly, on all of the queries themselves, I put a limit of 5. And so I did that just to control latency and cost, but you can modify all of those queries, and we'll talk about how you're going to do that next. But right now, just note there's a limit of 5 for all the queries. Thirdly, kind of going back to my point about modification and what I was suggesting earlier in this presentation, which is I really recommend that you modify this file and write anything and everything that you wanted. And we'll go into that in a second a little bit more. But last thing I want to note here is that you can also run queries directly from the Athena UI. And so I actually prefer, well, it depends on the project, but like recently I've been writing a lot of my queries inside of the Athena UI, so that way I can save and name them. And so this has been super helpful for me. But equally, you can also save and name them directly on this query underscore datasets.py file. So moving on, let's talk about customizing and expanding the queries. So as I noted, the file comes out of the box with essentially 4 options. So search by journal, search by author name, or search by field of study. You can rip these apart and make them your own, and I'd highly recommend that you do that. And so modify those pre-existing queries, add additional search criteria, add additional fields that you want to query over or add to tables. You can even apply a lot more complex filtering logic, and it's just like the beginning step. Like I said, I created this to try to take you guys from 0 to 1. And so there's a lot of those predefined queries that you can start with. Now, I want to highlight for option 4, inside of the terminal, you can also run a custom query. And so here's where I'm just saying, I'm selecting option 4, and then I'm writing out this query, which I'm saying select the title, authors, and year from whatever table I'm working on, assuming that those fields are present in that table, where the year is greater than 2015. So you can see you can run custom queries and really filter out papers that you want. Lastly, for advanced querying and joining of tables, you can use AWS Athena to actually join papers together, or tables together, excuse me. And so this is really, really helpful on the Mora side. I know that if I were to have to join externally outside of Athena, I'd have to decompress all of those files and then worry about joining them together. So the fact that Athena can query through compressed files is extremely, extremely helpful for us personally, based off the features that we want to create. And so I'd highly recommend that all of you guys get experience in joining tables together, just depending on your data needs. But here is an example that I wrote where I'm saying select the title from the papers data set, the citation count from the papers data set, and the name from the authors data set. And I'm saying from the papers data set is kind of the main table that I'm working off of, but I'm joining the authors data set on the author ID, and then I'm joining the citations data set as well on the citing corpus ID, which is equal to the corpus ID. And I'm saying also where the name is equal to John Doe. So what I wanted to highlight here and illustrate is that you can get really, really custom with your SQL queries. And so define your use case and then figure out a query that will help make that happen. So I'll move on to one of the last slides before going into Q&A. And this is going over kind of the best practices that I've found for self-hosting. It was really hard actually to collate and think about what are the absolute thing. I could write 5 slides about best practices truly, but I tried my best to consolidate, and I landed on these 3 buckets. So we have data management, code efficiency and optimization, and project organization. And so all of these are tailored to someone who's really at the beginning of their self-hosting journey, but a lot of these things will scale out with you. So we'll start with data management. The first thing that I want to highlight, a best practice, is the data itself comes in new line delimited JSON. I would stick to that format. It's an awesome format. And this really is just to avoid any corruption to that data. And overall, I think it will save headaches later down the line. Now, if your use case calls for you to have text data or something else, right, then figure that out. You're gonna have to. But I would definitely suggest if there's a way that you can just keep things in new line delimited JSON to avoid corrupting the data, you should. Secondly, this is more of like a recommendation from my own, these are all from my own personal experience, but naming conventions. I would really recommend that you maintain very consistent naming conventions across everything that you're doing, especially because we're handling very large data sets. And so if you don't want to have to download a data set and open it up and essentially waste a lot of time, I'd really recommend that you guys create some sort of naming conventions or standards and adhere to them across your entire project or whatever you're working on. This will save you a lot of time and headaches and just promote cleanliness. And then on the topic of cleanliness, I would definitely recommend that you guys optimize your storage. So I know for myself, about once a month, I'm constantly going through all of the services that I use and even my local computer, and I'm cleaning things up all the time. And so I would suggest the same to you guys. Regularly clean up any of those unused data sets, clean up any S3 buckets that you're not using anymore, and even your local files, just to avoid unnecessary cost and clutter. Moving down to code efficiency and optimization. For most, this first bullet point is the single most important thing you probably need to focus on in terms of optimizing what you're doing and making sure that you're writing good code, which is error handling. And so that is, without a doubt, you will run into errors. They happen. Now, with that said, if you're thinking about error handling, especially from the beginning, you can really resolve a lot of things before they even come up. And so how I personally do that, I use a lot of logging. I use checkpoints. I use backoffs. I use retries. And there's plenty of other failure strategies out there. But I would definitely recommend those are kind of like the four that ultimately help you in handling errors. And so I'll draw your attention to the right-hand side of the screen where I've included a retry and backoff strategy. And so all I'm saying here is that based off some status codes that I regularly see, I'm going to retry for a total of 5 times with a backoff factor of 1. And so this itself handles things like, okay, let's say you time out from connecting to S3, right? Or whatever services you're using, a retry and backoff is a great failure strategy and error handling strategy to use. Secondly, test queries. So because we're writing SQL queries more for that query datasets file, I'd really suggest that you test your queries first before running them and scaling them across, let's say, entire datasets and hundreds of millions of papers. And so how you can do that is you just use limits. All of the current predefined queries come with a limit of 5. And so I definitely recommend that you test your queries first before scaling them out based off whatever you're doing. Thirdly, on this section, modularize your queries. I'd really suggest that you create and save kind of reusable queries. This will just enhance your workflow overall, promote cleanliness, and I would just say help you in the long run. So definitely think about how can you modularize what you're doing, especially on that SQL side. It also does another thing that I want to note, which is if you kind of create, instead of creating like a master SQL query, it's really hard if you have a master SQL query that handles like 5 steps inside of it. It's really hard for you to decipher what's going wrong. And so if you have individual steps, you can clearly see, okay, it's failing at the step of joining papers and abstracts based off of this field, right? So once again, modularizing queries is a great best practice. And lastly, going back to the point about speeding up that download datasets process, there's kind of 3 ways that I would suggest you start with, and there's many more rabbit holes you can go down. But the first technique that I use is I use parallelization, excuse me. And so I will run multiple processes at the same time. And so this speeds up. So for example, let's say I'm going through the papers data set, I will write code essentially that allows me to create sessions and that allows me to, let's say, download 10 files at once, not just one file after the other. And so use parallelization, it works. Secondly, on this point, you can enable something called S3 transfer acceleration. And so that's done via the S3 settings inside of your AWS UI. And this definitely speeds things up. I don't have benchmarks, but I know from personal experience, it's definitely sped things up for me. And so you can enable transfer acceleration on S3. And lastly, to this point, offload your tasks with EC2. For those of you who don't know or are not aware of an EC2 instance, it's something that Amazon provides. Pretty much all the code I run that is somewhat of like a long process, etc., I offload a lot of things. Nearly like 80% of the things I do, I offload to EC2. And so there's a lot of benefits to that, but I think most importantly is because you have an instance that's tailored to one specific task, it can perform that task very well. It's not worrying about, your Google Chrome open or your Outlook email open as well. It's just hyper focused on that task that you give it. And so offload with EC2s, maybe especially that download datasets file, if you offload that to an EC2 instance, you're definitely going to see performance improvements. Okay, lastly here, before we move on to Q&A, I highlight some project organization tips. I know I've been pretty adamant about user stories, but they really help you. And so I definitely recommend a best practice is define what your goal is, try to do that through a user story, and then create technical requirements that you can follow. And once again, this just kind of puts your blinders on. It allows you to have a source of truth to reference when things go wrong and just stay hyper focused on what it is you're trying to accomplish. Excuse me. Secondly, in project organization, I'd highly recommend that everyone keeps logs and documentation. And so I'm kind of like a documentation nerd. I'm constantly documenting what's working, what's not working. I'm constantly keeping logs of running code and referencing back to them and seeing ways that I can optimize. And secondly, if things do go wrong, I have a log to troubleshoot. And so in all ways, in every area of what you're trying to do, I would recommend that you log and document as much as possible. This goes back to error handling as well. Lastly, I would recommend that you communicate with the Semantic Scholar team. Stay in touch with Chris, with Ashley, with even myself. I'm not formally a part of the team, but I'm more than willing to help you guys as much as I can. And so join that Slack community, ask questions. Going back to logs and documentation, if you have questions, I would definitely suggest that you include as much documentation as possible so that we're able to help you as quickly as possible. But with that said, it now kicks over to our Q&A. The floor is completely open, and I include some topics to consider when you're asking your questions there, so reference those. And lastly, I would urge everyone to check out Mora. So you can go to mora.io. And right now we're accepting beta testers. So if you want to sign up to become a beta tester, you can do that. And we'd really appreciate that. And secondly, I would love to connect with each and every one of you on LinkedIn and just stay up to date on what you're working on. And so you can scan that QR code. It'll go to my LinkedIn profile, and you can add me there. Otherwise, I'll pause now if there's any questions that I can help to answer. And thank you guys so much.
Here's a question in chat I'll read to the group. Thanks so much for the applause. There's one from Michael. How long do queries take for the data set for one table or for joins? Maybe Seth, if you have some anecdote examples of how long a query takes.
So if I understand correctly, the question is just pertaining to AWS Athena and running SQL queries and how long do queries take. It really just depends on what you're trying to accomplish. I know that if you're going through, let's say you're going through and you're trying to find a single corpus ID through the papers data set, it's going to have to query through the entire 100 million papers in order to grab that corpus ID. And that might take long. That might take up to 10 minutes. That might take even longer if you have a really large corpus. And so that's important to note. That's why I always recommend limits. And even further, I always recommend filtering out data that you don't need. So for example, ways that you can do that is you can use fields such as open access, that Boolean, true or false, and you can say, grab papers that are open access from the papers data set where the author name is this. And so that will help kind of narrow down that universe that you're searching. And so I'd always recommend, because queries do sometimes take longer, that you filter down the fields that you're searching, and try to get that corpus as small as possible. But if I can put a ballpark, basic queries such as finding a paper from a data set could take anywhere between 2 to 15 minutes, depending on where it is, because Athena searches top to bottom. And then other queries such as data joins could take anywhere between, once again, probably 5 to 10 minutes, 15 minutes. It just depends on how well you write out your SQL queries. So hope that helps.
Here's another one. Is there any guide on how to integrate diffs coming up every week onto your existing database?
I don't have one that comes to mind that's publicly available. I know we've gone through that process and thought a lot about it and have broken that process down. And there's a lot of different ways that you can do it. I would.
If I could jump in, I do have a link here in chat. I'll post this on the Google Meet and in the YouTube live stream chat now. This is from the Semantic Scholar tutorial page, and it gives a little bit of an overview on handling incremental diffs.
Okay, I would suggest the first question that I would ask is, do you need it to be automated or not? And that will kind of narrow down what it is that your scope, right? But yeah.
Here's another great question. For fields that are not present in the data set, for example, bibtex, do we need to call get details of paper endpoints for each paper?
I can answer that. So like with more, for example, we have a cite button, and we don't actually store that citation, right? We're calling the Academic Graph API based off of the corpus IDs that we're self-hosting. So the data sets themselves, and I'll kind of kick back to answer this question here. So this is what's available to you inside of the data sets. I know it's not clear. This deck will be sent out to you guys, so you'll have access to view this. But clearly you can see, as we look through the papers data set, we can even look through the citations. There's not a bibtex site, right? I think it's called, what is it called exactly, that field? Drawing a blank here. I was just literally working with it. I can't recall off the top of my head, but yeah, so for the fields that aren't present, for the data that's not present here, you'll need to still call Academic Graph API. Now, can you do that in bulk? Yeah, you can. You can use the bulk endpoint and call multiple papers and get their citation, the bibtex for all of them through the Academic Graph API. But that particular field that you're interested in is only available through the Academic Graph API. So I hope that helps.
Is there a tutorial or a simple solution to getting the papers from the data set in plain text format so that they can be read by LLMs for use in applications like GraphRag?
Yeah, I would ask, why not just embed them? Why would you use plain text? You can, for example, like what we do at Mora is we use embedding models across Hugging Face, and we push abstracts through embedding models and generate embeddings over them, and then we feed those into LLMs. And so I would suggest probably stay away from plain text, revert to embeddings. Now, I don't know your use case, and I think it was Chris Yates that asked that question. So Chris, if you want to connect after this and talk about your use case and talk about some options that you have, feel free to shoot me a ping on Slack. But you definitely can convert that JSON data over to text. But kind of going back to that best practices that I was saying, I would think twice about doing it just to not introduce data corruption. I'd maybe leave in a new line delimited JSON. But anyways, Chris, let's connect after this and we can talk about that more. Any other ones? Do you guys have any cool ideas about like what you want to build and want to talk about that even? Like the floor is completely open, so feel free to ask any and all questions.
Thanks for the presentation. I have a question regarding the diffs follow-up. In particular, is there a way to get a notification that, let's say, if the new batch of paper arrives, that, okay, it's ready and I can download it?
Yeah, you can set that up without a doubt. Now, this is where it's tricky. It's like we've set that up, and I don't know if I want to share that publicly, Elman, to be fully transparent with you. But I'd be happy to kind of share with you, point you in that direction, if that makes sense after the call. Elman, if you want to shoot me a ping. But there is definitely a way that you can create a pipeline that will watch for the post of incremental diffs, and then we'll use those URLs and update your corpus or whatever your self-hosted site. Without a doubt, that's an option.
Yeah, and then just to be transparent about my use cases, I want to set up something like alerts, where let's say, every week or so I get a batch of papers, and then you set a keyword, like for example, diffusion models, right? And then I would search for this corpus and then summarize the papers and send an email for myself. I have something like that for archive that I crawl archive myself, but I know Semantic Scholar probably parses a lot more that, let's say, Nature, Science, all the journals. And I just want to set it up and make it broad. And that's my use case. That's why I was asking is that, like, can I get like some ping that, okay, there's a new set of repo papers that got crawled by Semantic Scholar. We can download it, and then I can just filter them myself.
Yeah, you could definitely accomplish that. Like, I'm thinking about the individual steps. And so if you wanted to create some sort of an alert or something along the lines, that alone probably has about like 10 steps, and you would just create some sort of, once again, an automated pipeline that would recognize when the post happens. And then the subsequent steps, like for example, if you wanted to filter or look through them for a particular keyword, that alone would be kind of like a standalone thing. But yeah, it's definitely possible, Elman. And I would like to kind of, if you want to connect after this and talk about that, I can share a little bit about Mora's approach to handling and automating incremental diffs and the integration of that into our data management system. But yeah, so really cool use case though, Elman. It's kind of like creating a Google alert.
Yeah, exactly.
Super cool.
I just want to recreate that. Yep, thanks.
Awesome. Any other ones, Chris?
Yeah, I've got another question. I'll jump over to a question in our live YouTube stream. Any recommendations for best practices for something approximating full text search across the documents stored on S3?
Yeah, I think one, you need to decide whether you want to use a managed service or you want to self-host to accomplish that. I know personally there is a lot of fantastic tools out there that allow you to index and search across indices, excuse me. Some of those, just to name a few, would be like Elasticsearch, Vespa. Those are kind of more out of the box. You can even do it on MongoDB Atlas, etc. You could even create an AWS DynamoDB table and write queries across that table. etc. And then you can also do other cool things like there's really cool databases out there. For example, ChromaDB is a great one. Not Vespa, excuse me, I already said that. You have Facebook's Phase that allows you to store embeddings. And then you could do semantic search across those embeddings. There's also Milvos. So there's tons of options out there. It really just depends on your use case and what exactly do you want to search. Are you trying to just search full text across titles, maybe across abstracts? Are you using the S2RC data set and therefore you want to search across that? Your use case really derives what technical toolkit you would require to accomplish that. And so tons of options out there for you though. And yeah, you could definitely index and create full text. That's essentially what we did at More, but we did it using embeddings.
Great. I believe there's one more up here in chat. Let me scroll. We've got one from Sean Gorman. What's your strategy for increasing query inference speeds for all of this data at Mora?
Ooh, that's a good one. It kind of goes back to the idea around when I was talking about, like, I think there was a question about how long does it take to run SQL queries? And so ideally, you're always trying to limit the amount of papers, and I refer to it as an index because we index papers. And so you're always trying to limit the searchable index depending on a query. And so there's a lot of different ways that you can do this. In terms of speed itself, an easy way is you buy a managed service that has the infrastructure and ability to quickly query through items. So that would probably be the out-of-box easy thing. But there's plenty of other strategies that you can take. I would start with thinking about how can you, like let's say we have a corpus of 200 million papers and we have a query, and then we want to search. How can you decrease the size of that corpus first before you run the query, right? So I would think about that. I would think about, let me think about another thing that I've been doing recently. I mean, I would honestly say it depends on how your data is indexed, but searching across embeddings, for me, my experience personally as a developer has been a lot faster than searching full text. And that's because if you use, like, let's say you use something called nearest neighbor search, and you do some sort of vector similarity search, you're able to instinctively, at least the back end is able to see similarity very quickly, as opposed to scraping through each line and finding a series of keywords. And so if you want to increase or decrease search latency, I would point you in the direction of those two things. How can you decrease the corpus, your searchable corpus first before running a query? And then maybe point you in the direction of, why don't you search across embeddings? And that way you can leverage things like a reciprocal rank fusion model and leverage things like the similarity search or nearest neighbor search. That way you can decrease that latency there. So I hope that helps. And yeah.
It did, mate. Thank you.
Cool. Any other ones? What do we got on time? We got 4 minutes. I think do we have a hard cut at 11?
We probably should do a hard cut at 11, maybe for the remainder of questions. We're going to do a follow-up email as well as a survey, and perhaps we respond to the other questions along with a summary of everything we talked about after the webinar. Rodney did just share a resource for those with questions on embeddings, a link to Spectre 2 in our GitHub repo. So have a look at that. Seth, I believe you have a closing slide. Do you want to take the rest of it?
Do have a closing slide. And I just want to urge everyone, I'll pause here for just a couple more seconds. If you have absolutely any more questions, add me on LinkedIn. Let's connect and stay updated, and you can ping me there. Or once again, you can find me inside of the Slack community. So ping me there or Chris. With that said, we'll go to the closing slide. And so I'd ask everyone who's on, if you can scan this QR code and take the survey, or Ashley, if you want to post the link directly. It really does help the Semantic Scholar team continue to offer these webinars and improve your experience with them. So please take that survey. But in summary, what we went over today is kind of the ins and outs of self-hosting the data from Semantic Scholar. And so I really hope that you guys can have just that initial helpful resource that takes you from 0 to 1. And then you can scale that out depending on your use case. So once again, recommend you define that use case first and then choose the best tools and even the best data sets that meet your needs. So a couple suggested next step, join that Slack channel if you're not. Connect, share ideas, meet everyone, introduce yourself, and everyone there is more than happy to ideate and help you accomplish whatever you're trying to. Go ahead and move forward with cloning the repo and setting up your self-hosted setup there. So set up that environment. Ping me if you have any questions about that. Start running those predefined queries and then customize them based on your needs. And then lastly, you can start to then explore some more advanced options. So maybe dive into those advanced data sets like the one that Rodney shared. So the Spectre embedding data set, maybe focus on optimizing for speed, your queries. Just think about how can you take things a little bit from 1 to 2 and up to 10, up to 100. So that's pretty much it. I do want to call out a really special thank you to Chris, Ashley, Rodney, the Semantic Scholar team, broadly the team at AI2 for all that they do. Without them, truly, we would not have been able to build Mora. And so I cannot thank you guys enough for what you do and how awesome you are. And just really, really thank you. So cheers.
Thanks so much, everyone.